lecture 2. On this one, we're going to talk about 4 concepts of early algebra and also what are some other ways to structure the very first algebraic and numeric concepts. And then we'll also learn about some more explicit teaching approaches that we haven't discussed yet. Now, let's start with a little intro. What is the difference between simply like using numbers to get in your answer versus applying your understanding of how numbers work to problem solve and apply and do a little more? You may have noticed that there was this Juniper weight loss campaign. I think it was run, or it did run in February 2024, perhaps also in 2025. I'm not sure if it's going to start soon again. But there was this commercial like ad put on the sides of buses. Saying loudly, our clients have lost 200,000 plus kilos. Now, when I see something like that, and I do hope that this occurs to you also, is a question: what numbers, what kilos have been added? So this is the difference between numeracy and algebraic thinking. When we just simply use addition, we can just add up all kilos lost. But then if we dig a little bit deeper and use our understanding and like reasoning in terms of algebra, is Juniper, like what is counted as lost kilos? Are we reporting the net weight loss? Like what is the kind of like the end product of everything? Or just what was lost and then maybe gained back? So as an example, maybe there was one person that lost first 3 kilos, then 2 kilos, but then gained back 2 kilos. So did they count that this person lost 5 kilos because that's what like initially happened, or that they eventually lost 3 kilos because first they lost 5 and then gained back 2? What is being counted here? This is the picture of the campaign, so you might have seen that in the past. The gross loss in this case would be, the first person lost first lost 3 kilos, then 2 kilos, and the second one 5 kilos, and then 2 kilos. So like all that counted would give them minus 12 kilos, so 12 kilos lost. But then if we then, add back the kilos that were gained, back, then the net loss actually is only 6 kilos. And because this is a commercial campaign, we can I would think we can easily assume that they were reporting the gross loss and not cared about what was the actual result of using this product. That's the difference between simply just, we have certain algebraic functions like procedures such as addition, subtraction, and so on, and we can simply use them to find out some answers. But the goal is to gain a little deeper knowledge in terms of what can we do with these skills that we now know and now have, like addition, subtraction, and so on, competences and procedural skills. So let's get ready for teaching very young children, like early stage 1 children, these early algebraic skills. And I do want to emphasize that we're only starting to get ready for teaching. So please do not have the expectation of, after this lecture, after this week, or even after this course or this program, you now have everything. You know every single thing about teaching mathematics, teaching early stage algebra, or those kinds of things. do you think that you start getting some strategies, ideas, and like professional understanding, especially in terms of like where can you gain more knowledge and how can you develop further? So this is definitely the start for your professional learning. What might it mean to teach algebra for a 6-year-old? And you can just for a quick second visualize a 6-year-old. What is the kind of the state of cognition, um, motives, like motivations, like what are they excited about? Like how do they behave? How kind of like small kids they still are, physically even. And then like think about these mathematical ideas that we now start to teach them. What might be the things that they already know and can then connect to what you will be, what you will teach to them. Now, some of the things that studies have founded is that for a 6-year-old, numbers and algebra means that they're able to symbolize, represent, and transfer patterns. So, like understanding the idea of a symbol, understanding what patterns are, what they look like, where there is a pattern. They're able to repeat and structure, identify, generalize, and extend. What was noted also is that if young students are simply only taught to find answers to arithmetic procedures, like what is the right answer to 3 plus 2, imagine like maybe filling in worksheets, and just trying to check the accuracy of their answers. Then if that is the only thing that happens, then later on, even if they get very fluent in getting to those right answers, it'll be difficult for them to then extend that knowledge into how are we dealing with equalities, functions like equations, graphs, when it's more about like what is the relation between different numbers, or how might things logically work together, and those kinds of things. So it's not a sufficient foundation for like then later on creating and generalizing. So we do also need to emphasize things like explaining, like why is this the right answer, and not only just why is 3 plus 2 a 5, but then also like what numbers make a 5. Are there any other numbers? What numbers make less than 5? So really understanding the relations of different numbers. What is the sum of 2 and 3, and how does that differ from the product, for instance? Those kinds of questions. Not everything needs to be discussed on the first class where you start introducing addition, but like keep in mind these kind of questions, and then when you, for instance in this case, later on start introducing product, you can then come back to we already know how addition works, so what is the difference between these two different operations? Let's check a little bit further what is meant by 4 algebraic ideas that get introduced at the very early age. Those being quantities and whole numbers, combining and separating groups, which basically refers to or connects closely to addition and subtraction, comparing groups, and introducing patterns. So quantities and whole numbers. So we have this substrand representing whole numbers, and just understanding what numbers mean, what quantities, what is the idea of counting something. So when you start teaching or early stage 1, start with concrete objects. You can bring to the classroom things like blocks, beans, small toys, You can like start building your own classroom library. Hopefully and likely in your school there will be a store, like a storage of, useful manipulatives. You can also recruit your students to bring something, so they might even bring something that they want to, work on or can like use as their hands-on manipulatives. Show a small group, for instance 3 blocks, and say this is 3, let's count them together. 1, this is the first one, 2 and 3, and like really concretely like help students to internalize these things. Counting. Have students count objects in a variety of ways, such as using one-to-one correspondence, like 1, this is the first of the blocks, 2, this is the second, and so on. So like 1, 2, 3, like very like literally like and concretely showing how the one-to-one correspondence works. Ask questions while you're doing these things and activities. How many red blocks do you see? Can we count these blocks together? How can we do that? And so on. Visual representation. Use number lines or charts where students can literally place the correct number of objects to show quantities. So this is the connection between the number sequence in terms of like what digits, what actual symbols we have for numbers, and how does that connect with the to the number line. So what is the idea of a number line? And link quantities to numbers. Write the number, for instance 3, on the board and ask how many objects do we have here. Like, can you, using your own objects, can you make a group of 3? Connect the quantity to the written number. To combining and separating groups. So not only have we this, this aim of like really making sure that everybody understands quantities and like how to use the number sequence and what different representations we have, but then combining, separating, because obviously this is the foundation for addition and subtraction. Again, use concrete examples, like we have 3 books and I give you 2 more. How many books do you have now? And again, like literally count them, 1, 2, 3, 4, 5, and then at some point we don't need that, counting longer. Use blocks or counters to demonstrate this, counting out loud as you combine groups. You can make it physical, and do also bear in mind that oftentimes we use the same words here, such as, you have 3, pebbles, or you have 3 blocks, or you have 3 apples or something. So try also to use some creativity. Maybe sometimes it could be, counting leaves outside in the ground, or just about anything, and especially if your students bring up something, like try to utilize that and use that as your context. Model addition. Start with 3 objects, then add 2 more, count all objects to get the total. Discuss what happens, like what literally happens when you combine groups. You can even make a connection to that number line again, like here we are at this location of 3, and now we're like making 2 more steps forward, so we're gonna end up at 5. Model subtraction. Begin with the set of numbers, for instance now 5, take away 2, and the same way count how many are left. And again, like if you use the number line, you can show that now we're kind of like moving backwards. Discuss how removing objects affects the total. You can even have conversations like, but where do the removed objects go? Like, is there a story behind it? And again, you can use your students' imagination and have them create stories around these calculations. And then practice with more examples. Use similar problems and have students model their own manipulatives. Encourage verbalizing. First we add 3 and then we add 2 more, we get 5. So quantities, and then combining and separating groups. Comparing groups. So now we got like 2 different groups, and the questions then already now, but then especially later on, are often like, which one is more, like literally, like do we have enough money to pay our shopping, or which one is more, the price or how much we have in our bank account. So like those kinds of things. So we're talking about things like greater than, less than, and equal to. So again, use visual aids, set up 2 groups of objects, 4 blocks, 6 blocks, which group has more. Obviously we start with something very simple and we can literally count them. Later on you can even like make things a little bit more complicated and have groups that are like harder to compare at one glance, and then we do need counting skills, so it's also like a justification. Ask questions like, which group has more blocks? How can we tell? You can even make some humor out of it, like present that you have issues with counting, or losing one of them, or like just dropping one on the floor or something, so that your students can can have an active role of one was dropped, like, we have to also count that one, those kinds of things. And then also you can create towers, for instance, so like physically show that one of them is higher than the other. Real world scenarios have 3 apples and you have 5. Who has more? And then again, try to vary the word so that it wouldn't always be apples. We both have 4 pencils. Do we have the same number? Like, you have 4, I have 4. We can even go back to one-to-one correspondence. And then you can again be a little bit silly also, because that's that helps the classroom to feel like safe and exciting, and just like a shared space where conversations are welcome and so on. So like if you say something silly such as I have 3 dads and you have 5, so first I have 3 apples and you have 5. How about if it was 3 dads and now you have 5 dads? Who has more? And then that would give students an opportunity to be like, but nobody could have 3 dads, and so that kind of thing. So that there's a little more than simply what the numbers are doing, but a little more contextual things also. Not only does this bring some emotions and fun to the classroom, but also help students to understand what sorts of objects can actually be added, or are there any limitations, are there any restrictions, what things don't come in groups of 5, for instance, like those kinds of contextual or conceptual understandings as well. And then practice comparing. Procedural is give students several sets of numbers and ask them to compare, which one is more out of these, how about these, what about this. So that is procedural fluency. Coming back to the beginning, simply helping your students to get the right answer. That's one part of of what we're trying to, or what we will be able to teach this to children. And then conceptual, things like, in total 2 friends have 4 dogs. Do they both have what do we know about the number of dogs of the first friend? And obviously it could be that one of the friends doesn't have any dogs at all. So again, giving some space for your students to think about that, real life context, how do these things work? What does it mean that there are 4 dogs and 2 people? Are they the owners? And if they are owners, then there still are different options for the number of dogs for each. And finally, introducing patterns. This is one of the very foundational things that we want to build and develop on the early stage. Create simple patterns. Again, keep it concrete. Use colored blocks, Lego blocks, or pebbles, or bottle caps, or disposable mugs, something, and make a creative repeating pattern, like red, blue, something. You can ask your students to continue the pattern, discuss what makes the pattern repeat. maybe your students want to, oh, not just maybe, but they do want to create their own patterns also. So it's also one of the very good ways of activating your students when you apply problem posing, basically. So like your student can work in pairs and create number patterns for each other to then solve, and that also helps with differentiation, because they might kind of like challenge their friend, like, this one, so I'm gonna make you a harder one, and so on. Introduce growing patterns. Use numbers, 1, 2, 3, 4. That's a very simple one, already a pattern. 5, 10, 15, 20, or 2, 4, 6, 8. So this is already the foundation for multiplication. Multiplication tables are essentially patterns. And ask students what comes next in the pattern, what is the actual change, not just like what is the next number, what changes here. And also do identify and help your students like work together, like have these conversations in your class. Create this environment where it's less about how quickly it can be complete and like get all the worksheets neatly done and get all the right answers, but more like spend some time, take it slowly, have like these kind of like emerging or vivid conversations about yesterday when I went home and I made some toasts, this number came up. Give your students space to have these conversations, and while you are having these conversations, the work kind of like progresses. That doesn't mean that you have to have a conversation on all the time, but like do have space for such things. Identify patterns in real life. So again, like, where did you see, or have you seen any pattern? Are you able to identify any in your environment? Alternating colors in a rug, or the days of the week, or anything. And that could also be a good homework. And yeah, encourage students to find and describe patterns. I'm encouraging you to find and describe patterns around you. So maybe you'll find something in your weekly routine, or in your living environment, or in your clothes, or in your wherever. That would be great if you could identify at least one pattern somewhere in your life. Again, make a connection to a number line so that you can show that it's also like physical pattern. Now we have these 4 quantities: comparing and adding and subtracting, and then comparing and patterns. But it's only one way to structure. So there are lots of concepts in early stage algebra, and when we move forward, many of these kind of like overlap and connect with each other. So as a teacher, you don't have to again like memorize certain like categorizations or create. There is no correct and one and the only right mind map, or way to structure all these algebraic concepts. So if you open any other teacher guide, or maybe your textbook has group things a little bit differently, so you might encounter some other terms as well, such as here is just a list of just a few: trusting the count, so like knowing that the numbers won't change, the sequence remains the same. Place value, conceptual and procedural understanding, that's something we talked about already. Computations and arithmetic, number sense, algebraic laws, for instance, commutativity. So like lots of different terminology and ways of kind of like, here's how we can approach things. So just be aware that there's a lot of language. In the NSW syllabus, there is this division into 3. So quantities, whole numbers, supersizing. Supersizing means the ability or the act of identifying quantities at one glance. So if you look at, if there's a dog park and you look at it and you like immediately see that there are 4 dogs, that's stupidizing. If there are, many dogs and you literally need to count them, like 1, 2, 3, maybe there's like 29 dogs, so you won't be able to stupidize such a big number. Most of us, I believe, we can stupidize maybe like 6 items or 7, maybe 8. It kind of like depends also like how they are organized. So if they're like in a nice array that you can like literally see that there was 4 and 3, so you can almost like stupidize that there was 7, opposed to if they were just randomly there. But that's the name, that's the meaning of the verb. One-to-one correspondence, grouping and sharing, adding and subtracting, multiplication. So those are all kind of like connected or put under quantities. And then relations, so when we're comparing, again, like one-to-one correspondence is needed, like, because if there's one group where, like when there is no one-to-one correspondence, then one group is bigger than the other. When there is one-to-one correspondence, then they are the same, the groups are the same. So like, again, that is used under relations as well. Grouping and sharing, adding and subtracting, multiplications, and so on. And then patterns, so sequencing, multiplication, which again like also goes under relations and quantities. So you can see it's a kind of like tightly and densely connected network of things. I mentioned that if you open any teacher guide or maybe your textbook or something, there might be some other ways of categorizing things. This book by Simon and others, it's one of our course readings, one of the books that I can well recommend. It's by Australian mathematics education researchers who know exactly what is happening here. So, and it's been updated multiple times. So there are several editions of this book. So, and it's also very nicely written. So there are a lot of exercises for teachers and so on. So I think that's one of the books that I can definitely recommend for you if you want to buy one teaching guide for your mathematics teaching. Also available in the library. So this is the categorization that they use: equivalents and equations, which then include whole numbers, stupidizing, and so on. So kind of like the same as in the NSW syllabus, quantities. Generalization, which now kind of is almost the same than relations, comparison, reasoning, but has a little different kind of approach. Pattern and function, so again patterns, sequencing, operations. So there are different ways of categorizing things, and I think the most important thing is that you start building your own way of connecting things. And please do never think that this is the ultimate best possible way to ever connect certain ideas. Your students might have their own ways of connecting things, and it's good to have this openness to explore and investigate. And this is a good way of seeing things. Or if you come from this, if you take this perspective, then just be aware that there are certain other aspects in play as well. So you had explicit strategies to start teaching those early algebraic concepts to the small children. Then you will also use the whatever task resources or teaching textbook resources you will have with your students. No, but what exactly is explicit teaching? Because we've been talking about it a little bit already. If you look at the literature, which you don't need to do, there are a few terms like direct instruction or explicit instruction, or but in everyday, like casual, language, we typically use explicit teaching, and it refers to some kind of like I guide you through something so that you don't have to like figure out things by yourself, or I'm introducing you to something new that you haven't ever maybe heard or known before. So here is like I'm gonna help you now build your understanding or literally know what this term means, for instance. So typically it means teacher-centered. Effective teacher-centered approaches, like usually like in the research literature under explicit instruction or direct instruction, and it does mean that the teacher role is more active and the student role is less active. So the student kind of like follows what the teacher is asking them to do. Students may still collaborate with other students, especially after this sort of like initial explicit part has happened, and technology may be used. Technology can also take the role of the teacher and be the one that is like explicitly guiding the student. And whatever name we are using here, explicit instruction or direct instruction, in the research literature, direct instruction usually refers to something even more structured, whereas explicit instruction could sometimes just mean like the teacher can like scaffolding and facilitating. But direct instruction usually means that the teacher really like literally shows every single step. No matter what kind of like emphasis is applied, the idea is really to support your students and like gradually give some more independence to learners, so that like you can start with very direct instruction, or this is exactly how we're going to do things, and then like more explicitly guide that working where your students are like gradually getting a little more independence. A very commonly worded strategy for teacher-centered way of teaching is so this I do, we do, you do. So like one way of using explicit teaching or explicit instruction is simply like this is how you do it, like very directly instructing, but the kind of like the way to then like operationalize the whole thing is like I do first as a teacher. I'll show you how the example works, or how this procedure works, or how this thing is done. Then we can like do one example or a couple of examples together, and now we've had a few examples and you can like independently start working yourself. And especially if you think of something, think of your own work, for instance. So you start something like totally new, totally different, like a new platform or something. You need somebody to kind of like guide you a little bit, like get started here, for instance. And be great if you get some support, like let's do this together, and only then needed to do that yourself. I know sometimes you might just, go to a platform and kind of like play around and find your way around it. And that's also something that we can use in mathematics teaching, but then that's a different strategy. That's a more student-centered strategy, and also has a little bit different learning goals. And then also I'd like to add something that I call frequent exposure. So like basically what is meant by this is whenever something that is the goal of the teaching happens in a classroom, or seems to kind of like organically emerge, then you point it out, or you bring something up like frequently and regularly. So it's kind of like keeping it alive. So say you learn a new procedure, or you bring in a new term for your students. So then instead of simply just explicitly bringing it up once and then maybe doing some exercises with it, you keep bringing it up, or you keep pointing out that, did you know this, that this was again used, or now you use, Alison, you just use this word, so do you remember that we talked about that last week? So kind of like, keeping it, keeping those things alive. So that's also kind of like a teacher-centered way to making sure that there's like a lot of retainment. Maybe that's a good way of putting it. So a few kind of like hows here. So for instance, when we're counting sequence, if you simply like using like, I'm the one who is telling the facts, I'm directly instructing my students. So you simply tell, after 10 comes 11. That's it. Now we know the facts. I do, we do, you do. So it could be something like, as a teacher, you like create a pattern and then you do it together, and then your students can start creating and repeating sequences using, for instance, physical claps and stamps and so on. And then an example of frequent exposure. So like, for instance, for supervising, like you could give it as a homework, like, can you supervise again, like dogs in your dog park, like for 3 days in a row or something like that, or use one-to-one correspondence, like multiple times a week, for instance, just by saying like, hey, do we have the same number of students that we have seats today, or is somebody absent today, or something like that. So kind of like keep bringing those things up and using the terminology as well, not necessarily asking your students to use accurate like fancy terminology, but you as a teacher can start using those words so that they become more and more familiar. Here's another, like, this is adapted from Mathematics Hub, and you can also check out the link. So here's one kind of like example of I do, we do, you do. Like, review previous material, makes the goals of the lesson, make the goals of the lesson clear. Use small steps, well selected work examples, guides all the practice, all the exercising. Prepare questions in beforehand and give immediate feedback. Reteach, repeat if necessary. Usually it is necessary. Review at the end of the lesson. Continue to review material, and so on. And here is also there's a link that you can check out, where you can find some examples of like how to kind of like start explicitly explain things like, what is a pattern, like what kind of materials could we bring to the classroom so that students can start like learning about things like patterns. That was our lecture 2, and thank you for watching.